Both preservation policies and protected data policies require knowledge of all of the storage systems that are used to manage data. The management of a chain of custody requires tracking the storage systems that are being used. For each storage system, the data grid manages multiple pieces of information. In addition to REST name, the logical name, there's a REST class name, which is the type of storage, primary, secondary, or archive, an internal identifier, REST ID, resource parameters that are stored in REST info, the host address stored in REST loc, the operational status stored in REST status. A policy can be written that tests the operational status to denote whether sources are down or up. The resource type, such as HPSS or Web Object Scalar, are stored in resource type name. The path for storing files is stored in the resource vault path, and the data grid zone name for the resource is stored in resource zone name. Changes to a storage resource will cause changes to this information. Examples include changing the operational status, online or offline, and changing the resource vault. One form of data migration is to form a resource group of the original storage system and a new storage system, replicate all of the files to the new storage system, and then remove the original storage system. The name of the new storage system can be reset to the original storage system name. A report detailing this information should be updated periodically to track changes in physical resources and changes in access controls on resources. The administrator can move files to a new physical resource and keep the resource name even though the physical location of the storage has changed. Changes in access controls will require modification of the persistent state attributes that define access permissions for a user to a storage resource. Resource access name contains the resource name. Resource access resource ID contains the resource internal identifier. Resource access type contains the type of permitted access, read or write. Resource access user ID would then contain the user ID for which this permission is granted. A rule for generating a resource report, test resourcereport.r, is shown here. The rule is available in LifeLib Zone, Home RW More Rules, test resourcereport.r. The rule creates a query to retrieve the persistent state information stored for each resource. The information is then written to standard out. A version of this rule could be created to record a timestamp and write the information to a manifest file. You would then have in a single file a list over a period of time of all of the executions of this report, and you would be able to track changes that have occurred. The rule test resource report.r can be run on the lifetime library. You will find that 4 of the storage systems are listed as the type Unix file system, and one has the type MSO. The MSO storage resource is used to support microservice objects and workflows. There are multiple classes of storage. Cache, used for temporary storage, archive, used for persistent storage, bundle, used to manipulate tar files, and compound, used for managing workflows. Note that a Unix file system can be treated as either a cache or an archive or a bundle resource. Also note that some of the resources are located at SILS and some at RINC. Each resource has a unique resource ID. A log file can be added to the rule test-resource-report.org. Each listing of resource properties can be appended to the report and the additions can be timestamped. This gives a history of changes to the storage resources that can be used with audit logs to track the chain of custody. Take 7 minutes and complete exercise 72. Identify all of the storage resources being used to support your collection. Run the rule LifeLib Zone Home RW More Rules test-resourcereport.r. Check the properties of the storage resources. Is one of them an archive? Please load a paragraph describing your result into the lifetime library in the subcollection Class INLS 624 by the end of today's class. One way to track the multiple types of applications of policy-based data management system is to query the web. A unrestricted search on the term iRods in Google will generate more than 62,000 responses. Most of them will be related to the iRods data grid, although there is a fly fishing rod made of carbon that is called an iRod, and a Romanian Orthodox minstrel show about Herod the Great is also called an iRod. If the query is restricted to entries in the past week, then recent posts about groups using iRods can be tracked. This can be done by using the advanced search feature of Google and citing the last update to the past week. Such a query returns on the order of 60 hits. A typical posting is made by a project or institution that is using policy-based data management to manage distributed data. Examples from a query made in October 2015 include information posted in HPC Wire about production systems, information about new interfaces for genomics data grids, information on how to use a production system, publications, proposals, and job applications. The query finds projects in Europe, Asia, North America, and the US. The types of postings originally were papers published by the Data Intensive Cyber Environment Group, which developed the iRod software. Since the software was open source, projects would download the software and develop their own distributions that package their policies, procedures, and clients. Each project would then distribute the software to participating sites. Postings now cover areas related to job openings, blogs from persons discovering policy-based data management, and publications from projects using the software. We use the search on weekly uses of the iRods data grid to identify new applications of policy-based data management, integration of policy-based data collections with policy-based networks, new scientific disciplines that are building research collaborations, and new companies that are developing products that rely upon policy-based data management. The iRods consortium members now include storage vendors who are starting to integrate data management with data storage and companies managing genomic data. The consortium members also post information about iRods on the web.